Hi, this is Kevin Trainer, and welcome to part one of my lecture on chapter 5 of the Zelle third edition Python programming book. Chapter 5 is about sequences, and it addresses strings, lists, and files that are all sequences. Chapter 5 is really big compared to the other chapters we've done so far. And you probably should allocate about twice the time to it. Okay? Um, the the fact that we've put so many concepts in one chapter can be challenging. The thing I like about the chapter is that it really emphasizes the author's insight that strings, lists, and files are all kind of part of the same group of things. They're part of sequences. And because of that, I think I forgive the author for jamming so much information into chapter 5. I'm going to break up this lecture into three parts. In the first one, I'm going to kind of talk about the sequences aspect of this, and we're going to talk about strings and lists. In the second part, there's a lot of details with respect to strings and their processing, and we go through a couple of kind of interesting applications for string processing, encoding, and decoding of text. And then in the third part, we're going to go over files. So please allocate your time wisely and don't allow yourself to get kind of worn out by chapter 5. So off we go into part 1. I'm not going to read the objectives. The string data type is really kind of special in information processing applications because we do so much with it. We communicate so much with language, so all the typical text-oriented data that we have involves the string. Also, on the way into and out of the computer, even the numeric data elements that we work with are strings. So we have to learn a lot about them in order to do this kind of computing well. As we've learned already, strings in Python can be surrounded by what I call double quotes, which is the classic quotation mark, or by what I call single quotes, which the author calls apostrophes. And it's typical for any particular programmer to use one or the other fairly consistently. There is a way to use them together when we're trying to create a string that includes inside of it either a double quote or an apostrophe. Okay, so you adopt a style. Maybe the place where you work has a style, so you could be influenced by that. But one's not really better than the other, and it's just important to have a consistent style of how you enclose your character strings. So let's see. Here's an example of the author working at the command line. So he puts the string hello into string 1, spam into string 2. He prints string 1, string 2 because he has a comma between those two. He's getting a space between them, so he gets hello space spam. If we ask the type of string 1, we can see that it's the string class. if we ask the type of string 2, we can see that it's implemented with the string class as well. Now, when we get a string as input, typically we're going to use the input command if we're going to get it from the console. And inside the parentheses of the input function, we put a text a string that will act as the prompting text for the user. And here we've prompted with please enter your name, and the user has typed in John. And then we print the character string hello, comma, first name, and then it comes out hello, John. Notice that the input is not evaluated, and we say eval was a command that we learned early on, was a way that we could perhaps turn numbers expressed as text into numbers that were in an internal representation in the program. Of course, we don't have to do that for text because when we read text, it comes in as a string. So we don't have to further convert it. Also, we've also learned that whatever we're doing, we probably don't want to use eval because it's very hackable. Okay, so one of the first things that we should know about strings is that they are a sequence of characters. And because of that, there's all kinds of expressions we can use to manipulate the string to kind of either when we're building it or we're pulling it apart or we're trying to inspect it. Okay? The characters within a string have a position number, and it starts with 0. So it goes 0, 1, 2, 3, 4, 5, up from there. This is another typical thing in Python, as in all the modern programming languages, where we begin counting things at 0, not at 1. Okay? And it's possible to use an expression where it's a little bit hard to see what they mean by the syntax here, but we can ask for the character at a certain position, and they call that indexing. Okay, and it'd be easier to see if we go to this next slide, number 9. So here we have a graphic at the top, and it's meant to represent the context of the variable greet, into which we assign the value hello Bob with a space in between. And so we have a sort of a slot for each of the letters. We have 1 for the space. And then we begin to count these beginning with 0. So we can see that we have a string that's 9 characters long, and the index numbers of each of the characters are 0 through 8. So for instance, if in fact we use the expression where we use the variable name and then in square brackets we put an index number, then we're going to get the character at that spot. So if we say greet 0, we're going to get what's at the 0 spot, which is the capital H. And here we're going to say we're going to print greet 0, greet 2, greet 4, and we get H, L, O. Okay. Here we're assigning the integer 8 to the variable x. So we say print greet, and then in the index expression we say x minus 2, so that's 8 minus 2 is 6. So what's in the 6th position? Well, the capital B. So even though strings are it can be thought of as a kind of an atomic value in their own right, it's also useful and helpful to think of them as sequences of characters. And here, using these index expressions, we can pick out individual characters, which sometimes can be beneficial when we're trying to manipulate the data that's inside of a string. So in a string of n characters, the last is a position n minus 1. So we have 9 characters, and the index numbers are 0 through 8. So 9 is n, and n minus 1 is 8. So I think that makes sense. We can index from the right side using negative indexes. And this is a pretty expressive thing that we can do in Python. There are a number of string-related expressions that can either work from the left side of the string or the right. And if the index numbers that we use are positive, well, then it does the general case. And the general case is we normally want to pick apart a string from left to right, because that's the way we read here in the West. Okay? So the negative values for the index are the unusual case, which means that we start from the right, which is the opposite of the way we read here in the West. Okay, so if we say greet -1, we get the lowercase b. Greet -3, we get the uppercase b. Okay, so you might not be thinking offhand that you'd have a lot of use for that, but sometimes you do, and it's really nice to have a language that has such expressiveness to ask for things from both sides of the string. So indexing returns a string containing a single character from a larger string, so a string of length 1. We can also access a contiguous sequence of characters, contiguous, next door to each other. Okay, and that's called a substring. Okay, so it's a subpart of the overall string. And Python, again, has this really expressive capability called slicing. So it's a really compact way to describe a slice of the string. Okay, now could it be a single character? Yes, it could. You can have a slice that's a single character long. Could it be 40 characters, 160 characters? Sure, as long as it's a subpart of the overall string. So the important part is it's a subset of the overall string. So how do you do this? Well, you use the name of the variable, use the square brackets again, and then you have typically 2 numbers. I guess it could be a variable name, 2 values. Okay, they're integers. One is the start and the other is the end. Now, you're not going to be surprised because we've already seen this with respect to the ranges that we were using when we were putting together for loops. Okay. The start is the first one that we want. The end is, again, the first one that we don't want. Okay. Is that well chosen? Well, I'm sure you can find people who are not me who will tell you why that's artistically beautiful. I'm just not part of that club. Okay, and either way, you and I are stuck with the rules that they set up. So, as I said, start and end should be ints. The slice contains the substring beginning at the position start and runs up to but doesn't include the position end. So how's that the end? It's a number that will help you find the end. It's one past the end as far as I'm concerned. Okay, so remember this. Also remember that we start counting at 0. Okay, so when we're dealing with strings, or we're dealing with lists, we're dealing with any of these things that we count, we start counting at 0. It might not be intuitive for us, but at least it's consistent. So here we go. Here's the same variable, greet. It's populated the same way with the string hello Bob, and we're looking at what various slice expressions would return. So 0:3 would be HEL. 0, 1, 2. Why not HELL? Well, the 3, the second L, isn't that the first one we don't want? Yes, it is. So just HEL. 5:9. So we start at 5, and we don't go to 9 because that's the first one we don't want. That's good because we don't have a 9. So we should get space Bob with a capital B, and we do. No entry, colon 5. Okay, if we say no entry, we started at the beginning. Okay, so we start at the beginning. That would be with this capital H, and 5 is the first one we don't want. So we're going to get hello, and we get hello. Greet, start at 5, colon, no entry, start at 5, go to the end. So 5 is the blank, and we go all the way to the end. So blank Bob. If we say greet, no entry, colon, no entry, we'll get the entire string. You might ask yourself, then why not just say greet? And I would say, well, I think that would be easier to code and maybe easier to understand. But I guess when we introduce the slice expressions, and we introduce the idea that we wouldn't have either a starting entry or an ending entry, we wanted to be complete and describe what would happen if we neither entered the starting nor the ending entry. We would get the whole string. How many times somebody's actually going to put that code into a program is another matter. So some more things to do with strings. Can we put two strings together into a longer string? Yes, we can. So that's called concatenation. Okay. A good way to think of it is we glue two strings together. And what we've done is that we've used the plus operator in another context. So when you use a plus operator in the context of numeric types, it means addition. When you use the plus operator in the context of string types, it means concatenation. For the curious, it turns out that in computer science, we call this overloading the plus operator. It has, in different contexts, it has different meanings. And this is a common practice in modern programming languages, that the plus between two strings means concatenation. Repetition builds up a string by multiple concatenations of a string with itself. So you could say string asterisk 10, and we would get, the result would be a string 10 times as long with our string repeated 10 times. Now, there are times when you want to know the length of a string. Okay. Now, it seems kind of foolish when we ask for the length of a string that we simply just typed in as a literal value. It's like, can't we count? Well, yes, we can count, but we typically are asking the length of a string that we just got from either, the user typed it at the console, or we read it from one of the files that we're going to learn about in the end of chapter 5. And so we don't know the length of the string at hand. Okay? And so the length that we get back is a count of the characters, and it's a count. It's not an index, so it doesn't begin with 0. So, for instance, if we ask if we have 4 positions, we've got 4 characters, and we ask the length, we'll get back a 4. You don't have to worry about getting back a 3. And here are some interesting expressions where we're combining concatenation, multiples, 2 multiples plus concatenation. It's really pretty, there's a lot of expressiveness here. You can use your imagination to figure all the various things that you could do to combine strings. And of course, if we ask the length of spam, we get 4, but we wouldn't ask this because we can count. Okay, it's more important to ask the length of something that somebody just typed in and we don't know exactly what that was. The other thing that you can do is that you can actually use a for expression to iterate over the characters in a string. So you can iterate over any kind of sequence with for variable name in string, okay, and you get them one at a time, one character at a time. Here we decided to print, CH I guess stands for character, where we, I don't know why we didn't say character. If you or I were coding this, I'd like to see a variable name more meaningful than CH. Okay? At a minimum, care. What, we're all out of type that day. We didn't have an AR. But here what we've done is we're printing each of the letters, and we're using the option of the print where instead of a new line at the end, we're using a space. So we get S space by space space all the way to the exclamation point. Okay, so how do operators work? How do operators and expressions work when we see when we're working with strings? Well, the plus is concatenation. The asterisk is repetition. The square brackets with one expression inside is indexing. The square brackets with 2 expressions inside separated by a colon is slicing. And we can use the function len and then pass the variable to get back the length. And again, the length starts counting with 1. Okay, we're actually counting the characters, we're not indexing them. And it's possible to iterate over a string because it is a sequence of characters, and we can iterate over any kind of sequence. Now, one of the things we're going to see by the time we're finished with the chapter, that means we've already seen in previous chapters that we were able to use for in order to iterate over the items in a list. We've now seen that we're able to do it in order to iterate over the characters in a string. That's another kind of a sequence. We're going to find out when we get to files in part 3 of the lecture that files are sequences as well, and we can use iteration as a way to process the characters and the lines in a text file. So what I really like about the chapter, other than it being kind of long, is that it really emphasizes this wonderful, elegant feature of Python that character strings, lists, and files are all just different kinds of sequences, and similar operators will work on them. In particular, the most powerful one that they share is this last one on slide number 17, the for in iteration expression. So, and if you can really think of these things as sequences to be iterated over, you can really gain a lot of power. Okay. So this is the first sample program. And here's what we're trying to do. I'm not going to go over every line of it. We're trying to get some data in, right, from the user, and we want them to give us their first name and their last name, and then we want to use a combination of the letters in their name to form a typical username that you would use for a system. Okay. So what we do is we prompt for first and last, and we say put them in an all lowercase because we don't want to fool with capitalization. And typically we in usernames don't want to support capitalization. And then we say the username equals, from the first name, we just want to take index 0, that's the first letter. And from the last name, we want to start at the beginning, and the first character we don't want is 7. So we want 0 through 6, which is 7 letters. So we get 1 from the first name, 7 from the last name, and that's going to give us a total of 8. Now, I just want to point out that the comments that we use in some of the sample programs probably wouldn't be the best comments for real programs that you were doing on your day job. I've emphasized a number of times that comments, we typically put some up at the beginning to get people oriented as to where we are. And after that, for the most part, our comments are kind of statements of intention. They're not kind of play-by-play, okay? My criticism of the comments here on slide 18 is they're really play-by-play, okay? Which on a teaching slide, I think is okay, but on in a program that you were doing for your organization, this would be too chatty, okay? Okay, so here's an example. They entered John and Doe, and then the uname. God forbid we would actually use enough characters to say username, perhaps user underscore name, equals JDoe. Okay, and we had what? Donna Rostenkowski, which would be Drostink. Okay, so this is typical string processing. Maybe not something you've done a lot of, but pretty easy to understand. Kind of fun to play with. I think you do well to kind of play with this a bit and get the feel of it. the author here is kind of typing at the command line. Um, we're in my class, we're using PyCharm. Create a little program. One of the things that I've done, I don't think I've shown you yet, is that I typically have a project that I call Frankenstein, which is kind of my mad scientist project. And anytime I want to run an experiment, some sort of mad information scientist experiment, I just put a little program into Frankenstein. So what I would have done is I would have created a program here, not typed it in at the command line, and I would have had a chance to run it several times and have some fun. These textbook authors are very fond of the Python command line. In my day job, I don't really use it very much. Simple string processing. Okay, so this is so what we're going to do is we have a couple of slides here we go through, and we're going to do a typical thing where we're going to get the number of a month, and we want to turn it into some kind of a string label for that month. Okay, and we go through a first solution that is really old school. Okay, this is the way we used to program when I was a boy. Okay, and I haven't been a boy for a long time. It's an interesting idea, but not really something that you would do. The last version that we show you is maybe something that you would do. So don't get hung up on the first version here. So what we could do is we could take all the abbreviations that we have and store them in one big string. And because we know that we can pick strings apart, and we know that we have things like slices, which we can come up with a numeric expression for a slice and pick out just the part that we want, that we'll be able to come up with the code to pick out just the month we want. That's all there is. Is this the best way to do this I'm recording this in the fall of 2018? Certainly not. Okay. Was it the best way to do it in 1968? Well, maybe yes. So maybe 50 years ago, this was a good approach. But it's instructive. Okay. So we use the month number as an index for slicing the string. So the month abbreviation equals months. That was the long string that we have. And we say pos to pos plus 3. So that's position to position plus 3. So yeah, you're just going to, you have a position like the M for May, and the first one that you don't want is plus 3. You don't want the J for June. Okay, so you're going to get pos plus 1 plus 2, that's what you get, and you don't get plus 3 because this is the first one you don't want. So January, the number is at position 0. February 2 is at position 3. March 3, position 6. We say, you know what? There's a pattern here. I can reduce this to a formula. Yeah, you can. So let's see what formula he comes up with. He says that the position, which again, it's like we don't have the ink for the type. Pos is a horrible variable name. Position is a good variable name. Equals n minus 1 times 3. What is n here? N's a month number. It's another horrible variable name. Okay, month. We're not short letters. We're all good typists now. Plenty of room. Okay, so I would have said position equals month minus 1 times 3. Okay, and then he can say the month abbreviation, he's going to take from pos to pos plus 3, and again, plus 3 is the first thing we don't want. Okay, so don't program like Zelle. Okay, don't program like it's killing you to type every letter in a variable name or a function name or a program name. There's plenty of letters to be had. Just type away. Be descriptive without being overly wordy. Okay. One weakness of the method is it only works when the potential outputs have the same length. How could you handle spelling out the months? Well, if you want to do something that is high function old school, what you would have done is you would have made the entry for each month, you would have padded it with blanks so that they were all the same length. So instead of SCP, you would put September, and I forget how the longest length, but you'd pad them out with blanks. Okay, this is a dying art. It turns out that strings are really a special kind of sequence, so these operations also apply to sequences. So this is an interesting slide because it kind of sneaks in something that's pretty interesting. Okay, so what's this first expression we have? Well, it's a list with 2 items, 1 and 2. And then we're going to plus this with a list that is 3 and 4. So what happens if you plus a list in a list? You get one list that is a concatenation of those 2. So it kind of works like strings. Okay? What happens if you take the list 1, 2 and you say to repeat it 3 times? Well, you get one list, 1, 2, 1, 2, 1, 2. Okay? What if you have a list that has a lot of single characters, A through F, and it's called grades, and what if you ask for the 0th one? Well, you get A. What if you want grades 2 to 4? 0, 1, 2, C and D? You get C and D. What if you want to know what the length of the list grades is? It's 5. 1, 2, 3, 4, 5. Again, when we ask for the length of a list, just like when we ask for the length of a string, we get a count, okay? These aren't indexes, okay? So even though these would be numbered 0, 1, 2, 3, 4, the length of grades is 5. Okay, strings are always sequences of characters, but lists can be sequences of arbitrary values. So there's nothing about the concept of a list that says it has to be a list of homogeneous things. Strings are sequences of only characters. And as we'll see, we use a Unicode character set. So we can have really any character in the Unicode character set. But we don't have like any other types of things that go into strings. So they're a very limited kind of sequence. By comparison, a list is a very general kind of sequence. And here you can see we have an int, a string, an int, a string. Perfectly valid. Now, might that be useful or not useful? Sometimes, certainly you want an understandable pattern in the way you store your data. Okay, if you have a bunch of data that you put into a list called my list and it's just helter-skelter, well, it's going to be very hard to do meaningful processing on that. Okay, so whereas you can put whatever kinds of things you want into a list, you would probably want to put them there in some kind of orderly way so that you could expect to retrieve them in an orderly way. So we can use the idea that we can make a list as a way to solve the problem that we had before with months. And he goes, oh, we can just have a list. Instead of having to pick apart a string, let's have a more explicit list where we have the values for the months. And I think this is a great idea. It's just halfway there. There's no reason that they have to be 3 letters. So what we're going to do eventually is we're going to put the whole name there, okay? And the nice thing about a list of strings is they can be different lengths. The good thing about lists is that they're homogeneous, potentially, okay? So let's go a little farther. So what he wants to be able to say is month abbreviation equals months n minus 1, okay? Because for the first month, January, the month number is 1, but of course the index numbers in lists begin with 0, 2. So when you want month 1, you want months 0, so hence n minus 1. And he's saying that this is a lot more intuitive and straightforward than what we had before. Oh, absolutely. Much better. When we start to use the whole month name, it's going to look even better yet. So here's all the code to do that. I don't want to really review the code because I think it's a half measure. Okay. And having a hard time getting to my next slide. There it is. And he talked about the n minus 1 calculation. Okay, that makes sense. But now he comes on slide 30 and he goes, oh, really, we didn't have to do that. We could have put in the whole month name. And yes, you could have. We also could have started here, right? Okay, so why we went back to things, again, that I was doing 40 plus years ago, picking things apart in order to do that, well, I don't know. Maybe we figured that with the modern tools that you have now, you just won't suffer enough. So we have to show you how bad things were in the old days. Well, perhaps. But this is a decent solution. So we use the same math in order to retrieve real month names. And still, we have to convert. We have to take the number of the month and subtract 1 because we're going from counting on the months to indexing on the list. And indexing begins with 0 and counting begins with 1. So we need a translation. Okay, now we're going to get to another point about lists and strings. Remember, they're both sequences, okay? And they're both programming constructs, right? But it turns out that lists have one property that strings don't. Well, they have a couple. We already talked about it. Lists can hold homogeneous things, and strings can only hold characters. So that's one difference. Here's another one. Lists are mutable. What's mutable? It's a computer science word that means changeable. So one can change the items that make up a list and still have the same value object in the computer. Okay, you don't have to create a new list in order to, for instance, add one more item to the list. Or you don't have to create a new list to swap the first thing on the list with the third thing on the list. You can do that in place. Strings, on the other hand, are not mutable. They're not changeable. And you might say, you know, Kevin, we've been doing things where we change strings, so I'm pretty sure they're changeable. And the answer is, well, they appear to be changeable because what happens is when we assign a new value to a string, that variable name just points to a new object. Okay, so it looks like the object changed, but really the original object is initially still there. The new object is there, and we're pointing to it. And then eventually, if nothing else is pointing to the original object, it gets garbage collected and it goes away. So, you know, did we change the string? Technically, no. Right? So, for instance, here, if we have my list has got 4 items in it, and then we assign just one, okay? So we said my list has that in it, and then it has that there. I don't know what the 15 is for the life of me. My list 2 equals 0. My list 34, 26, 0, 2. Oh, I'm sorry. Never mind. Okay. So here when we say my list 2, we're not making an assignment, we're making an index expression. So my list 2 is the third one, 0, 1, 2. It's 15. And then we can say into my list 2, the third position, I want to plunk a 0. So then you can say show me my list. And the third item on the list is a 0, right? Now, so you can actually change the values that are in a list. You can add values. You can take values away. They're very changeable. They're very mutable. Not so with strings. So my string equals hello world. If we ask for my string 2, that should be a lowercase l. It is. If we decide that we want to plunk a p in there, it says, oh, no, we can't do that. Type error object doesn't support item assignment. So even though if we said my string equal p, it would have taken the whole string and replaced it by the string of p. If you actually tell it to go mucking around inside of a string and only changing a part of it, it says, oh, look, I don't want any part of that. Strings are unchangeable, okay? If you gave me a new string, I would point to it, okay? And that's kind of like changing a string, although it's not. But if you really specifically tell me to muck about in hello world and put a p where the lowercase l is, I quit, because strings are unchangeable. That's what's going on. Okay, so think about this. It might turn out that lists are a more flexible data structure, even if we're trying to process text. And we'll see an example of that before we're done. Okay? Because they're mutable or changeable. Be right back. Actually, this is the end of part 1. Instinctually, I wanted to take a pause here. Okay, so at this point, we've talked about sequences, right? With a lot of examples coming from strings, some of the examples coming from lists, and kind of a general comparison that that they have like properties, strings and lists, because they're both part of a larger set of things called sequences. In part 2, we're going to be talking more about strings all by themselves. See you there.